Hi, everybody, and welcome to the ASU Interplanetary Initiative Fall Transmission webinar. I'm Lindy Elkins-Tanton, Vice President for the Interplanetary Initiative and lead of the NASA Psyche mission. This regular event started about 5 years ago as a way for each of our projects to report internally on progress. And in recent years, we've moved it online and invited anyone interested to come see what we're doing. We've just completed our 5-year report on Interplanetary, and I'm happy to say that we've seed funded 30 research projects and reached 8 times in follow-on grants and philanthropy, what we gave in seed funding. And we have more than 30 active external collaborations, and we're constantly working on how to improve interdisciplinary. Oh, can't hear me. Why can't you hear me? Still can't hear me? Can hear me. Okay, cool. Awesome. Sorry, I got a, oh, Taryn is telling me she can't hear me, but everyone else can hear me. Okay, I'm guessing it's everybody but Taryn. And so I was just about finished with my intro anyway. So we're constantly looking at ways of improving the work that we do, the interdisciplinary, intersector research and education. So I'm really excited to see our updates today, and I'm going to turn the event over to our Deputy Director, Jessica Rousset.
Thank you very much, Lindy. Hopefully everyone can hear me. Welcome to our fall transmission webinar. Super excited to have you all here joining us today and having a great group of our staff present all of the great work that we're doing. Before we get started, just a quick reminder, next slide, please, that this is a, perhaps Sally can't hear me. You guys can hear me. Just to advance the next slide.
I wonder if there's a problem in their office. I might just run down there.
Okay, thank you, Lindy. I appreciate that. I'm going to signal for now. Next. There we go. Thank you. So this is a Zoom webinar format. We've been mindful to keep these meetings to an hour and to deliver great content to you all. So we will not be doing Q&A for this hour. However, we would love to hear from you, of course. And so at the end of the webinar, we'll give you lots of ways to get in touch, and we'll send you a recording of the webinar tomorrow and a request for some feedback. That is always appreciated. Next slide. Okay, great. And so just as a reminder, we've changed our format for this fiscal year. So we're doing 4 transmission webinars. The winter and summer webinars are focused on our seed-funded interdisciplinary pilot projects, which Lindy referred to. So on December 15th, we'll have a mid-year progress update from all of our teams. And then at the end of the year in June 15th, we'll have a final report out for the year. So please join us for those. And then in the spring, March 15th, we'll have our spring transmission webinar, which will cover similar content that we will be discussing and sharing with you today. Next slide. And so for today, we're going to welcome some new crew members. We'll talk a little bit and give you a little teaser on our upcoming Mission Interplanetary season podcast. And we'll be giving you lots of updates on our learning program. So we have 2 exciting new ways in which we're engaging students, and then lots of updates and growth in our technological leadership degree program. The Interplanetary Lab will be beaming in from Sun Devil Hall to tell you about a lot of the progress and activity happening there, lots to report out. And lastly, we'll share with you some updates on our key partnerships. So before we get going, I'm sorry, if we could go back. I just want to give a quick update because we're excited to offer for the 2nd year in a row our Interplanetary Fellowship. So this year, we are going to be partnering with the School of Historical, Philosophical, and Religious Studies to welcome our fiscal 23 Interplanetary Fellow. And the theme for this year will be the intersection of religion, spirituality, and space exploration. So we're very excited to offer this again on this particular topic. We'll be announcing and posting the job opportunity over the next few days. So please look out for that and share it with folks that you think might be a good fit for this opportunity. So now, welcome to our new crew members. So this quarter, we had 2 new lifeguards joining us. So these are our student workers at the Interplanetary Lab. We call them lifeguards because they are the ones operating the lab and making sure that projects are being carried out effectively and safely. And so welcome to Genevieve Cooper. She's a computer science major, and welcome Sam Cherian, who's an aerospace engineering major. Shaitan Nagaraja is a graduate student in user experience, and he joined our marketing and communications team recently as an interaction designer. You will actually see some of his great work today, specifically on the podcast, which we're going to hear about next. And also, last but not least, welcome to Mason Miller, who is a sports journalism major. And he is a student producer, also working on bringing us this next season of Mission Interplanetary, which transitions us perfectly to introducing Lance Garavi, Associate Director at the Interplanetary Initiative. He's also the podcast producer extraordinaire for Mission Interplanetary. He's a professor of the School of Music, Dance, and Theater. Mission Interplanetary started as a pilot project, and we're now launching our third and, of course, best season. So over to you, Lance.
Great, thank you. So yeah, Mission Interplanetary, it's a podcast about space exploration. Now, yes, there are other space podcasts, but this one is the best. It's the official podcast of the Interplanetary Initiative, and in true Interplanetary Initiative fashion, we focus on the big questions. It's not a podcast focused on the wonkish details of the technology or the physics or even the latest headlines, who launched what into where this week, but it's focused on the big questions, the mysteries to uncover, the challenges to overcome, and the opportunities within reach. So each episode features a conversation with thought leaders who are imagining and designing and building the future of humans in space. And we have two amazing hosts. The former NASA astronaut Katie Coleman and scientist author Andrew Maynard, both of whom are ridiculously charming and fun to spend time with. Have them talking into your ears, and we are very, very excited about something new that we're having this season. We have formed a partnership with System Sounds. They are a group that produces sonification of space data. They take data. They have contracts with NASA and JPL and others, taking data from space and translating it into sound in the same way that some people take data and turn it into an infographic or a chart. This is turning that same kind of data into sound. And so we're partnering with them on if you're familiar with the podcast, the regular segment we do called Sounds of Space. So the podcast has had 2 successful seasons so far, 150,000 downloads from 135 countries. And we're getting ready to launch season 3. The first episode drops October 4th. And I gotta say, as Jessica said, I gotta say she's right. I think this is gonna be our best season ever. We have folks like Alex McDonald, who's the chief economist of NASA, Chris Hadfield, super famous astronaut, Tracy Drain. We've got Amber Strawn, who's the deputy project scientist for the JWST, the Just Wow Space Telescope. And we're asking questions this season like, how will we govern on the moon? What do we do about orbital debris? What does religion have to do with space exploration? Or what is the future of space food? So please check out Mission Interplanetary. You can find it wherever you get your podcast. You can catch up with previous seasons, recommend it to your friends. Don't forget to subscribe, leave us a review, but be on the lookout. Next Tuesday, episode 1 of season 3 drops October 4th. And I think we have an awesome video. without sound.
Can you hear it?
Yeah, you have to actually enable sound in Zoom. Oh, maybe we can put the link to the video in the chat. I urge you to check it out. Chetan, who Jessica just recently introduced, created this. The podcast team created the trailer, and Chetan made the audio for the trailer, and Chetan made the awesome video. I urge you to check it out. Share widely on social media to all your networks. Anyway, we're really excited for what we have in store for you. So go check it out wherever you get your podcasts. Thank you.
There it is. Thank you, Lance. And we are, the first episode is going to drop during World Space Week, which is focused on sustainability and in space. And our first episode will address just that, the issue of debris, orbital debris. So please don't miss it. And so thank you, Lance. We'll move over to our next topic and sharing with you all of the great developments in our learning programs. So for this, presenting today are Alicia Hayden, Academic Success Coordinator, and Eric Stribling, lecturer. And they will both be covering all the updates in this area. But first, I wanted to give just a quick shout out to Catherine McConaughey, our Director of Learning, who is out on parental leave. We miss you, and we look forward to having you join us for our winter transmission webinar. In the meantime, I will hand it over to Eric.
Hi, excuse me. Hello, I'm Eric Stribling. I'm a lecturer with Interplanetary Initiative, and I teach the designing and making pathway for technological leadership. So can we go to the next slide? Great. So I would like to introduce the Interplanetary Online Research Scholars Program. This program, funded through the Hours Grant Program from the College of Liberal Arts and Sciences, offers online students the opportunity to participate in research with ASU faculty, which is an experience that is normally just limited to on-ground students. So this first of its kind program at ASU supports both the ASU charter and the college's commitment to excellence, access, and inclusion. And the Hours grant addresses the challenge of increasing access for online students to participate with faculty research at a large scale. Next slide. So we currently have invited 24 students across 17 different majors, which includes technological leadership, communication, history, political science, astronomical and planetary sciences, women's studies, anthropology, and many more. And these students are participating in 6 different II pilot projects. And just one example, there in the Justice, Equity, Diversity, and Inclusion, or JEDI Space pilot project, students have hit the ground running by doing background literature research, which is going to inform a white paper. And this white paper will advance our work with Orbital Reef, which you will hear about later from Chase. As a general reminder, we will share our general programs about our pilot projects during our winter transmission in December. And students who might be interested in future opportunities can email me directly at estribly, that's ESTRIBLI at asu.edu. And that's it for me, and I'm going to pass it to Alicia.
Thank you, Eric. My name is Alicia Hayden. I am the Academic Success Coordinator for our Technological Leadership major and our student engagement programs here in Interplanetary Initiative. So since the launch of Technological Leadership Bachelor of Science in fall 2020, we have seen steady growth in our immersion and ASU online programs. We have had 2 students graduate, and we'll be seeing 7 more students graduate in 2023. So this is outstanding and amazing. Excited to have them moving through the program and finding success. Today, I wanted to share our spring interplanetary course offerings, update you on the new minor that we are offering, and share a few of our technological leadership students' experiences with their internships. This spring, we will be offering several exciting course options. All courses, with the exception of astrobiological arts, are offered both for our ASU online population and for our in-person students. In inquiry, students will be exploring big questions in a collaborative research setting. Our recent questions have included: how do we design livable cities in space? And does life begin in hot water? Our spring big question will be announced shortly. Eric is excited to be teaching the design and making 3D printing and fabrication, which is a space-focused makerspace course where students learn how to make things with their hands in an engineering-like way, while also thinking about social needs and ethics. So if you need help enrolling in this class, please email me directly so I can offer you some assistance with that enrollment. Creative Future Studios is all about giving the power to students to figure out how to run their own projects and make up their own course experience. So students really guide the work that they're doing in this particular course. And then finally, astrobiological arts is a twist on the inquiry process that combines art and science. Students will conduct research into astrobiology and create art in response to their discoveries. That one sounds super fascinating to me, but any of these courses can be taken as an elective. So students who just has a general interest in interplanetary research or having a better understanding of the future of space can take these courses as an elective. But we also invite you to participate by joining as a technological leadership major, or as adding the new technological leadership minor or interdisciplinary studies concentration. So we launched the technological leadership minor and interdisciplinary studies concentration this fall. Students choosing to add the minor in tech leadership or by adding the interdisciplinary studies concentration can enhance their educational experiences by developing skills in collaborative research, technology and design, and interdisciplinary leadership skills. The minor and IDS concentration are available to ASU online and immersion students. And as of yesterday, we've had 16 students already add the minor, and 2 students have already added the IDS concentration. So we're seeing some growth there already. Students interested in adding the minor should speak directly with their primary academic advisor, but I'm also available for any questions that you may have about courses or course offering. Technological leadership students are required to complete at least 2 internships before graduation. So fun fact, I looked this up yesterday, since fall 2020, our tech leadership graduates and students have completed 2,800 plus internship hours. So it's an outstanding amount of learning that they are happening and contribution that they are providing to our partners. This summer, we had students complete some standout internships. At Stellar Amenities, our intern considered the question, how do we make space comfortable and sustainable for individuals long-term? And as part of a small team, our intern worked on a product called the Experience Pod or XPod, which is a module astronauts interact with to experience sensations they otherwise could not get aboard a space station or habitat. In the Office of the Chief Technology Officer for Washington, D.C., our intern applied communication skills, gained in technological leadership courses like Inquiry and Creative Future Studios. The student honed their skills of communicating with subject matter experts by asking questions and seeking clarification. And while interning with the Luminosity Lab for their Procter & Gamble Home for the Future 2080 project, our intern felt like they learned 3 years of knowledge in multiple categories in just a few short months. Even though it was a lot of work during that condensed time frame, the intern was very grateful for the incredibly fun and educational experience that they had. So if you are looking for interns for this next spring semester or the next academic year, let us know if you're interested in adding any of our technological leadership students. Our students are looking for both remote and in-person experiences. And then finally, I'd like to introduce our brand new program here, Space at ASU Student Ambassador Program. And I know there's a few of you watching, so let's see you introduce yourselves in the chat and just give a little wave. But I'm excited to introduce the inaugural cohort for the Space at ASU Ambassador Program. The Interplanetary Initiative is leading the efforts in this pan-committee project to engage students in discussion on space exploration, habitation, and commercialization. 13 students have joined us from a wide variety of majors, including sports journalism, economics, political science, history, aerospace engineering, astronomical and planetary sciences, biology, Earth and space exploration, neuroscience, engineering, robotics, and astrophysics. The Space at ASU students ambassadors will represent units across ASU engaged in space activities to their peers and external stakeholders. We look forward to sending our ambassadors to a space-focused event at the new ASU California Center in Los Angeles on October 6th. If you are in the space industry and would be interested in mentoring or supporting these students, please contact me. If you're a student and are interested in participating in this program for the next academic year, please reach out to me as well.
Thank you, Alicia. This is really a powerhouse group. We're so excited for the launch of this program. I want to specifically also give a shout out to the New Space Initiative and the School of Earth and Space Exploration who have been tremendous partners in getting the Student Ambassador Program off the ground. So thank you, Alicia. Thank you, Eric. Now moving on to the Interplanetary Laboratory. I want to sort of introduce this by saying that this is an extraordinary facility here in Sun Devil Hall that is a shared resource. It's available to faculty across the university, to outside partners and industry members and students. So we want to get the word out that this is an asset that is available to all, and we would love to collaborate very broadly. So presenting today, we have Joe Dubois, who's our senior engineer in the lab, and we have two of our wonderful lifeguards, Chandler Hutchins and Ben Weber. Over to you, Joe.
Thanks, Jessica. We're coming to you today from the heart of the Arizona State University Tempe campus. The Interplanetary Initiative Laboratory is between the bookstore and the MU. And the next time you're on campus, be sure to stop by. Our doors are open 5 days a week, sometimes on the weekend. Danny Jacobs directs the lab. He couldn't be here today. The senior engineer. The lab, the majority of the operations of the lab are conducted by the students. And we have Chandler and Ben here, and they're going to take it away and go through all the slides. We're on a little bit of a time crunch because we're doing so much at the lab. We have 20 slides in 20 minutes. So just pretend we set the speed of your YouTube to double and we should be good. Take it away.
Chandler, you're first, but we need a slide change. So
Yeah.
Okay. So yeah, we have our mission statement, which kind of just goes through basically that we are this lab and we want to open the lab up to all students, all types of engineering, physics, astrophysics, and then other types of students as well that come in and just want to get their hands on different projects, hardware, software, and then moving forward through the slides. So we have a lot of different engineers on our project, and these are just some engineers that have been helping us on Lightcube and Dora, some external engineers that were either interns or recent hires that aren't lab lifeguards such as me and Ben here, who run the lab, but they work on specific projects and they're very useful for us. So we wanted to highlight them here.
Can we go back 2 slides just to highlight the lifeguards that are running the day-to-day? Other way.
There, yeah.
One more. There
Yeah,
we go.
so here's you see Danny Jacobs, our lab director, you see Joe, and then you have me, Christopher, Ashley, Ben, Sam, and Genevieve. So Sam and Genevieve you saw earlier are the new lifeguard hires for this year. Great new additions to the team. And we all have different backgrounds from mechanical, aerospace, electrical engineering, computer science, to handle from hardware, software, and everything in between. So now we can go forward. Okay, so then going into kind of a little bit about the lab quickly, we have a pretty large facility here, 6,000 square feet, which is really nice to have students involved in it, specifically undergraduates and master students, some PhDs as well. And so the lab itself is kind of an open area that can facilitate meetings, whiteboard, you can come in and do homework. We support all different types of projects that we'll go into throughout this presentation, as well as some of the classes like Eric has in our facility. And moving forward. So you can see here, this gives you another image from the other side of it. You can see some of the TVs in the back there that are black. Those are the ground station terminal areas that are usually on. So we can kind of remote into our ground station, which is on Physical Sciences H building's roof, which is on the other side of campus. So instead of going there and actually operating it from there, we can kind of remote in from the lab and get students involved with looking at the globe and kind of seeing satellites pass over in their orbits, as well as we have a kitchen, we have coffee, water, toaster oven, kind of, you never have to leave the lab. You can just kind of stay here, do your work, do your homework. It's a pretty good atmosphere. We have a popcorn machine. So yeah, and we're constantly changing the lab, moving it around, probably monthly, maybe even weekly, kind of change it up so everyone gets like a fresh aspect of, it kind of shows the dynamics of the lab. And then moving forward. So now where we are right now, you can see this is the electronics lab. So we have a lot of testing equipment. We have oscilloscopes, signal generators, power. We have a lot of RF equipment, including a new Field Fox VNA. We also have a lot of 3D printers and we're getting more all the time. So we can do a lot of prototyping. We also have a resin printer, so that's really helpful for more precise prints. And we do all of our board assemblies pretty much in-house, specifically for LightCube, which we'll go into a little later. And so this area is really nice from the beginning of the process when we're just designing it on KiCad to kind of going in and soldering, pick and place, and actually going through our testing of our boards. So then we'll move forward to the hardware lab. And so this is the mechanical testing lab. So we have 2 thermal chambers, which can go from -75 degrees Celsius to 200 degrees Celsius. And then we have a thermal vacuum chamber, which can go from regular altitude to a -4 torr. And then we have a CubeSat table, vibe table, which can vibe a 1U CubeSat to a light 6U CubeSat. We also have a fume hood, so we can do all of our resins. We can do solar panels, and that's what we've been using it recently for LightCube. And then we also have a clean room, which which we'll use for our flight assembly, flight hardware assembly. And then, typical saws, screwdrivers in all that sense, drill presses. So we can kind of do all of our prototyping, manufacturing in-house. And then as well, we just found out that our CNC machine that we recently purchased is going to be here within the next 2 weeks. And so once we have that, we could start machining our own frames, our aluminum frames, and kind of be able to do an entire CubeSat basically in-house, which is our goal from the beginning. So we can kind of manufacture from ground up. And then we've been working on designing a attitude testbed for ADCS system. So we've been kind of working through different iterations, starting at a 1 degrees of freedom with the magnetic field, and then kind of going through a mass balancer. And so now that we've received our ADCS system from our Dora CubeSat, we can kind of hopefully start building up our ADCS testbed and moving through that. So that's what we've been working on for a while now. So now, next part, yeah.
So all that environmental testing and room that we have for our capabilities and equipment is being used for these 4 projects: LightCube, Dora, Roamer, and Charlotte. These are projects that we have in the lab that students are currently working on as of now. Certainly there's students behind us, in front of us, all working on these projects in various forms. So next slide, we'll go over with LightCube. LightCube is a 1U CubeSat through ASU and the Interplanetary Initiative Lab. It was originally proposed by SDSL/Jaime a few years ago, and it is an outreach mission through NASA to lower the barriers of space, connecting to the night sky. The objective of Light Cube is to be able to send up a radio signal to it, and from there, be able to see a light flash in space. The payload will be really easy to trigger, flashbulb visible from the naked eye. Our delivery for this is December 2022. So coming up very shortly, we are in a little bit of a crunch time for this. Our partners are listed there, most notably some students within the ASU ECE department, the SETI's Universidad and Vega Space Systems, which was a previous lifeguard at ASU, who has now gone on to make their own space system. We have a lot of student workers that we had listed above working on this project, doing various things between battery testing, vibrations testing, and gravity gradient analysis. Next slide, we go into DORA, which is our 3U CubeSat satellite. This is a joint mission between our laboratory and the LOCO lab. DORA is a technology demonstration. We are here to demonstrate laser communications between satellites to increase transmission rates of data. Partners, again, similar partners that were listed in LightCube. We are making big connections with these people. Again, delivery is in November 2023, so a little bit more time, but we're still working on it currently. And again, we have several student engineers working on this at the moment, doing various things of the flight stack structure, the integration of all the components, some thermal analysis on the solar panels, as well as payload analysis as well. As we can see, Chandler right here holding the ADCS unit, which we purchased for this spacecraft. It was very cool. In the next slide, we have a project study, which is ROAMR, a 3U by 3U by 7U cube satellite. It's a little bit bigger than the standard cube satellite, but we're still working with cube satellite components. We're working with HAL Industries and the Space Force, doing a project study, like I mentioned, on what might this cube satellite look like. The main payload that they're testing is water thrusters and robotics arms. And our part of this is figuring out what other components need to be a part of ROAMR. So we have students working on this currently, trying to figure out, we have students working on this currently, doing various things of ADCS analysis, as well as some structural analysis and some thermal analysis, really getting some hands-on experience with a proposal that we'll present at the end of October of this year. End of October of this upcoming month. Next, we have our final project that students are currently working on, which is Charlotte. Again, this is a joint project between our lab and Luminosity Lab. We love Luminosity Lab. They come and use our facilities for a lot of stuff, and they have great projects in the aerospace field. Charlotte is a lunar spider, essentially. Our part of this project is to develop a lunar regolith test bed, which is very similar to a sandbox to simulate the lunar environment. We are also doing some thermal testing for them, as well as some structural analysis that we might have along the way. Their project is also due at the end of October, so they have the report to be written up by then, and we are giving them the required data that they need by their due date. And that closes up our lab projects, and I'll hand it off to Chandler to go over our, that closes off our external projects. I'll hand it off to Chandler to do our lab projects.
So we have a lot of internal lab projects, as I mentioned earlier, the ADCS, but today I'm just going to focus on two of them, which is our TVAC and then the lunar test bed. Next slide. So yeah, starting with the TVAC, we previously presented on this during the last presentation, and we've constantly just been adding on it for the last year or so, 2 years even. And so we started with our TVAC, which was just a high altitude chamber. We added electric control, we added thermal abilities in terms of heating. And so during the summer, we started adding cooling. And so we want to be able to go from 100 degrees Celsius down to minus 130 degrees Celsius with liquid nitrogen cooling. And so part of my project, and then Matthew, a previous lifeguard who has since graduated and gone to Blue Origin, he and I have been basically designing this liquid nitrogen platen. And so if you can see in the left picture is where we started. We basically had a big, a very large platen with a lot of drill holes. And then that was a 1/4 inch tubing. We found out that with this small tubing with the liquid nitrogen, we had a lot of oscillations. It really wasn't getting very cold. We then very poorly made the middle picture there is the 1/2 inch tubing. And so that actually ended up getting very cold. And so that was a bench test that we did just to make sure that the liquid nitrogen was going to flow a lot smoother through the 1/2 inch tubing. We ended up getting to about negative 100 degrees Celsius on that aspect. And then we went with the 3/8 tubing, which is a little bit smaller than that. And then a much more refined plate. And so you can see in that right image, That's actually testing apart from Charlotte on there. And that platen has actually been able to get to minus 130 degrees Celsius. And so we're actively testing with that one. And then we'll work our way up to even bigger platen. So and then with drill holes as well. So we're able to do mounting with lots of different types of testing projects that come in throughout the next couple of years. And then next slide. So part of working with Charlotte is they need to do lunar regolith testing. And so for us, we're going to make this lunar test bed, which Ashley, one of the lifeguards here, have been working on. And so essentially it is just a box that is capable of holding lunar regolith. And then it is a gravity, basically an assist to kind of simulate that lunar gravity for this Charlotte project, which is like 200 plus pounds. And so being able to simulate that with a pulley system and then also have the lunar regolith in it, it'll be a really good chamber or test bed to kind of have at ASU for further lunar testing. And so we'll be planning to build that. Actually, they're cutting behind us. We had them stop for noise issues. So they're cutting the material and kind of assembling it this week. And so hopefully we'll have this lunar test bed over the next, over this month, we'll be doing Charlotte testing.
So in our progress within the lab, we have grown significantly with the amount of visitors and users that we have. So back in last fall, when I first joined the lab, we probably averaged around 5 people a week, which was the 5 lifeguards who worked there. Now we are averaging roughly around 10 people per week outside of the student orgs. And then including the student orgs, we're getting a lot of users and visitors coming by. So as we can see, user visits in 2022, 623 people have come by and stopped by and done something at the lab. So speaking on those student orgs that we have in the lab, in the next slide, we can see some of our important lab visitors. Most notably, we have Ascend, which has started using our laboratory space back in the fall of 2021. Has continued using it for their 2 semesters of projects and now this upcoming semester as well. They work in conjunction with the Arizona NASA Space Grant Consortium. They were originally a team of 6 members. In this fall, they now have 28 members on their team. Great user, great increased users for us and great increased users for them as a project. Some of the mentors are Dr. Thomas Sharp and Dr. Jean-Joël Das from the School of Earth and Space Exploration. Additionally, we have some other organizations through the lab, which includes SDSL and their projects of CanSat and their intro project as well. SDR, all the aerospace clubs really are utilizing our space for either the collaboration lounge for meeting space or using our hardware lab for assembling some of their projects. In our next slide, we go over some of the events that we've attended at ASU. So last April, we attended Rocketpalooza, which was an aerospace related outreach event. We roughly got 100 people interested in our lab and interacting with us. It was a really fun event. They launched off some bottle rockets. It was a little bit of a party, had some music. It was pretty fun. Most recently, we've had the Passport to ASU and Interplanetary Mixer. Passport to ASU, we had 243 lab inquiry forms filled out, which is a lot of people coming by, getting interested in this. Granted, I think a lot of the swag from Taryn helped, but it was very, very notable. We had a lot of people coming by, interacting with us. And that we also debuted our LightCube demo, which we're intending to have for our future events, which is a similar payload to LightCube, except for we're having it a little bit downscaled so it doesn't blind people nearly as much. The Interplanetary Mixer was our first fall event in the lab. We had around 30 people attend. We presented from technology leadership, which was mentioned earlier in our presentation, SDSL, one of the Fulton student organizations. Next Level Dev was another Fulton student organization, in Ascend, which I previously mentioned. Did some lab tours, got some new people interested in the lab and interacting with us.
So then our final slide, we've been attending these conferences, which have been really beneficial to our lab and growing kind of connection throughout throughout the summer. And so the first one that we were able to attend is Breakthrough Discuss. And so you can see me and Ashley in that picture. Also, Jessica was there. And so we had a great time with the Breakthrough Initiative. And so they invited us out to California and Santa Cruz. It was beautiful there. And so we got to kind of meet a lot of people in industry, a lot of meeting professors, hear a lot of interesting talks and kind of grow our knowledge overall in the aerospace field and kind of see what the next future for the next decade or even beyond looks like in the aerospace field and kind of bring that knowledge and kind of see what challenges or projects that we want to work on at the lab for the future. And then we attended the small sat right before school started this semester. And so that was really cool. You can see that picture there. You can see Joe, me, and Christopher from the II side. And so we got to show off LunaMap. which is on the SLS right now. We also got to talk about Lightcube and Dora, and then also kind of grow our connections with all these companies that can kind of supply CubeSat components. And so being able to have the knowledge of who's supplying EPS boards, ADCS systems, communications and antennas, and kind of being able to know like where the stops are for all these components is really going to be beneficial for us over the next year or so, as we kind of build up a reservoir of all these companies and kind of be able to supply us with the CubeSat components for either Lightcube, Dora or Roamer, or even our future proposals for our CubeSats. And so with that slide, I think that kind of finishes the lab up. But yeah, definitely let us know if you have any questions about the lab. You're welcome to stop in. We're at Sun Devil Hall. There's a big poster usually outside that says, "Welcome to the II Lab." And yeah, we're open Monday through Friday from 10 to 5 p.m. And yeah.
Thank you. Thank you all three of you so much. Yes, and just a shout out also to the New Space Initiative, with whom we joined forces at the SmallSat conference. And it's been nice joining forces with a lot of the different space units across campus to showcase all that we're doing here at ASU. Also, I do want to just emphasize that, yes, Interplanetary Initiative has great swag, so please come to our events. And just a last point for the lab is, we have been working with a lot of small businesses, small companies on STTRs and SBIRs grants, and we've been very successful with some of those. So we encourage you to reach out to us if that's of interest. And certainly we'd like to connect more with faculty across campus on projects. So thank you again for all those amazing updates. Now we'll move over to our last presenter, Chase Castle, portfolio manager, who will be giving us an update on a partnership that has garnered a lot of interest. And I'm sure everyone will be very interested in hearing where we are with our relationship on Orbital Reef with Blue Origin and Sierra Space. We're coming on close to a year of this relationship. So I will turn it over to Chase to give us those updates.
Awesome. Thanks, Jessica. Next slide, please. So part of my responsibilities at the Interplanetary Initiative include work on the Orbital Reef University Advisory Council, and I'm really excited to share with you today the progress we've been making. For some context, Orbital Reef is a commercial space station being developed by Blue Origin and Sierra Space in partnership with ASU that has plans for operation by the end of this decade. And with NASA's announcement of the retirement of the International Space Station in 2031, commercial space stations like Orbital Reef are being developed to fill a scientific need of conducting experiments in low Earth orbit and microgravity environments. But beyond the experiments, these new commercial space stations will also provide an opportunity for general commerce, as well as space tourism opportunities that provides lots more access for people to experience the wonders of a low Earth orbit. Next slide, please. For those who are unfamiliar with the Orbital Reef University Advisory Council, the council was launched about a year ago and is made up of 15 universities across the US, as well as the UK and France. The vision for the council is to be the premier advisory body for educators and researchers seeking to inspire, innovate, and collaborate in low Earth orbit. Its mission is to leverage our collective assets and expertise to advance activities in space through a lens of equity, social responsibility, and broad impact. Next slide. So the council is made up of 3 subcommittees, including research support, research guidelines and ethics, and societal connection. And collectively, we have 33 participating faculty. The research support subcommittee helps to streamline access to expert and university laboratory resources like our own, to help new groups get access to the right people and resources to conduct research in space. The Research Guidelines and Ethics Subcommittee is focused on establishing robust guidelines for conducting research ethically and safely in this shared facility environment offered on Orbital Reef, and brainstorming how these guidelines create a more equitable and accessible space. In fact, we're currently, as Eric had alluded to earlier, engaging these online undergraduate research students from our pilot projects to assist in writing a white paper on diversity, equity, inclusion, and accessibility that we plan to have published in the next few months. The Societal Connections Subcommittee is tasked with developing a science, technology, engineering, arts, and mathematics-focused outreach program to reach new and underserved communities, to engage them on low Earth orbit and microgravity environments, and to inspire the next generation of people who want to work in space. Next slide, please. So earlier this year, ASU had the great opportunity to host Blue Origin and Sierra Space at our Dreamscape Learn facility on campus. We had the opportunity to spend the day going through different virtual reality scenarios to understand how these VR programs might be used to promote student and general public learning about Orbital Reef. And the Dreamscape Learn VR experience is one of many examples of how ASU is leveraging its unique assets as a partner of Orbital Reef to encourage learning and inspiring a new generation of careers in space. I look forward to keeping all of you updated with our progress as ASU enters our year 2 of this partnership with Orbital Reef. We're always looking for new students and faculty to engage with on our projects, including external collaborators. So please don't hesitate to reach out to me if you're interested in engaging or learning more about the project. Thank you so much.
Thank you very much, Chase. And for those of you that are not familiar with our Dreamscape Learn environment, separately, that is a really compelling partnership with Dreamscape Immersive. And so if you also are interested in learning more there, I encourage you to go and demo those experiences. They're quite unique. We're doing great on time. So next time for the YouTube speed, we can probably dial it back to 1, but that was great. I think everyone appreciates having a little extra time in their day. So just to wrap things up, a reminder that our next transmission webinar will be in the winter. It'll be December 15th. It'll be all pilot project focused, and we have 9 of them. So super excited to hear about their progress in December. Please join us for that. And then next slide, please. If you are not yet subscribed to our newsletters and our updates, please do so. Here's the QR code. Feel free to, of course, reach out to us anytime at interplanetary@asu.edu. We absolutely would love to hear from you. You will be receiving, as stated up top, a recording of this webinar. We'll also ask you for some feedback. Always love to hear how we can do better. And until then, I wish you a great day. And thank you so much again for tuning in. And thank you to all the great team members at Interplanetary Initiative for all your amazing work and for these great updates today. Thanks, everyone. Bye.